In this video, we're going to continue our exploration of using right triangles in application type situations, or just applying the math of right triangles, or the trig of right triangles. So this is an example in which we're going to utilize what we call a contour map. And if you've not seen a contour map before, it's essentially this. We say all the horizontal distances are accurate, just like you would read a map. You notice down here we have a key. We say 1 inch on this map, and you'll notice it's not drawn to scale. But 1 inch on the map, given with this little bar here, is 1,600 feet in real life, horizontally speaking. And as far as the contour goes, we say, okay, so the contour interval is 40 feet. That means for every ridge here, this little line here, it looks like concentric rings on a tree, but is a 40-foot height elevation. Okay, so let's go ahead and consider this situation that I've got listed up here. We say, suppose that Bob and Ed are climbing Bishop's Peak, okay? And they're located at points S and A on the contour map. So we have S, we have A here, we have this horizontal distance between them. Sorry to draw over the S there. But we say Bob is at position S. So we say Bob. It's okay to draw on these things, and I hope we can see that there, possibly if I do it in a different color here. Bob. So that means that Ed is point A here. But the question is this: what is the angle of elevation of Ed to Bob? Recall that an angle of elevation, we say there are angles of elevation and depression. They are always related to what we refer to as the horizontal. The horizontal, or the horizon. Okay, so elevation would be up from the horizontal. Here's our elevation, and depression. Depression would be down from the horizontal. So we're concerned with his angle of elevation. So it seems that Ed, standing lower than Bob, what I want to know is what is his angle of elevation if he's looking at Bob down here. So we're going to need to know a few things. First of all, we need to know how far apart they are in a horizontal sense. But before we find that, let's go ahead and fathom this situation. We're saying, okay, so if this is point A, we'll call this A, and then point S, it's kind of like saying Bob is standing uphill from Ed. So this would be the distance here. It's of course not straight line, but we can say their horizontal distance from one another is actually this distance here, okay? How far they are in a strictly horizontal sense. And so this horizontal distance we need to find first. We're also going to need to know how high up they are from one another. So let's go ahead and find these two amounts. Now I have to let you know a little insight. I stole this out of a book, of course, but if we had the book in front of us here, you would need to find the horizontal distance by measuring how much of an inch they are apart from one another. And I'm going to go ahead and spill the beans here. This blue segment from A to S comes out to be 3/8 of an inch. Okay, so that'd be like, here's my inch down here. We could split it in half. There are 1/4 of an inch, and these would be like 1/8. Okay, but essentially, this distance here is as much as 3 of these 1/8 of an inch. And so what we need to ask ourselves is 3/8 of an inch, that'd be 3/8 of an inch, is 3/8 of 1,600 feet. So let's go ahead and start by finding this. We say, what is 3/8 of 1,600 feet? Now when we say of, we can just go ahead and multiply. In math, of means multiply. So we'll go and throw this over 1. Our 8 and our 16 cross reduce here. So the 8 becomes 1, and it goes into 16 twice. But this would essentially become 200. So 3/8 of an inch on this map, horizontally speaking, would correspond to 600 feet in real life. So we know they are a horizontal distance of 600 feet from one another in a horizontal sense. Okay, so now let's consider this. What is the height difference between them? So that would be over here, we'd say the height difference between them. We're going to have to read the contour now. So we say the contour interval is, for every ring, is a 40-foot difference. Now it's kind of hard to see, but we see like this line right here is where Bob's contour line is here. We see a difference of 1 here, 2 here, kind of like 3, ish here, but about 3 contour lines. Okay, so if one contour line represents 40 feet, then 3 of those contour lines, let's not write that, 3 of these 40-foot intervals on our contour represents a height difference of 120 feet. So here's the deal. We know that there's a height difference, vertically speaking, of 120 feet and a horizontal distance of 600. The question was, what is the angle of elevation from Ed's line of sight to Bob? So if this is our horizontal here down here, okay, we say the angle of elevation would be this angle up from this. We're going to say this is angle A. But now all we need to do is set up an equation in which we relate this A, this thing we want to find, this thing we don't know, to 2 things we actually do know. And so what we'll do is we'll relate them to the 2 sides we know. We'll switch over to green here, but we say which trig function would relate angle A to the side opposite and the side adjacent? This would be tangent. We're going to go ahead and set up our equation here. The equation would be this. The tangent of our angle A would be equal to 120 feet over 600 feet. Okay? And so one thing's apparent. Our feet cancel out. We lose a 0, as a matter of fact, on both of these. And then 12 and 60, well, I'll be honest with you, this reduces down into 1/5. And so we can go ahead and convert this to a decimal. Essentially, we could say, well, then the tangent of A is equal to, let's see here. Wait, we had 12 over 60. That is 150. I'm just making sure here. Is 0.2 or 0.2000 if we want to go out to 4 significant figures there. That'd be 5 sig figs, but in this case we'll go out 4 places after the decimal. So here's where we need a calculator. I'm going to go ahead and open one that I have up here. I got this calculator. We'll drag it over here. But we say, okay, so if tangent of A equals 0.2000, we have to undo this tangent, undo it. So we're going to do tangent inverse of both sides. So tangent inverse of the left cancels out my tangents and leaves behind A is equal to tan inverse on the right. So this is equal to what my calculator tells me when I type this in, 0.2. So we say tan inverse of 0.2. Let's go ahead and find our calculator here, right here. So we say 0.2, and I'll shift. We want tangent -1. So we say about 11.3-ish degrees. Now I want you to keep in mind, our original figures went out to the nearest whole number. Not a bad idea to go extra, one extra place value. So we'll go about 11.3 degrees. But that's what we'd find out. We say A, this angle, is approximately 11.3 degrees. And I just want to talk real quick about reasonability. 11.3 degrees is not a big angle. That means like all the other degrees that are complementary to 11.3 are up here. But all this I'm getting at is this. 11.3 degrees is quite small, and you'll notice that the side opposite the 11.3 degrees, 120 feet, was very small relative to the 600 feet that was adjacent to our angle A, which is opposite the larger of the two acute angles. So, cheers.